In this section, we're going to talk about partial melting and how different types of igneous rocks or different compositions of igneous rocks form due to partial melting. So there is a sequence of events that occur because originally all the crust was ultramafic. So it had a composition the same as the asthenosphere. Over time, what happened as these rocks partially melted, so the arrow is going to represent partial melting. So the ultramafic rocks become partially melted and they create mafic rocks. The reason why this occurs, because if you remember we talked about partial melting, basically in partial melting, the silica-rich minerals melt first. So when the ultramafic rocks are melted, even though they have a low content of silica-rich minerals, those minerals represent or melt first. So the silica-rich minerals melt first, therefore the rocks produced from the partial melting are or have a higher percentage of silica. So mafic rocks have more silica in them than ultramafic rocks. So through the partial melting of the ultramafic rocks, you're concentrating the silica and you're creating mafic rocks. Remember, mafic rocks generally are much less in silica than felsic, but they still have more than ultramafic. So this occurs at spreading centers, or I'm just going to type mid-ocean ridge. So the mafic magma, which I'm going to erase this and type in magma. So you partially melt the asthenosphere at mid-ocean ridges, and that causes crystallization, and this also occurs at the mid-ocean ridges or spreading centers. And once they crystallize, they then become oceanic crust. So remember, oceanic crust is basalt or gabbro. Remember, we talked about this in chapter 21. At the surface is basalt. As you go deeper down, you get gabbro because you have slower crystallization. Okay, so then we're going to partially melt our mafic rocks, and this is going to occur, so once again, partially melt. This is going to occur at subduction zones, because once the oceans are spreading, when you get subduction, that's going to cause the mafic rocks to partially melt, and you're going to get mafic or intermediate, just depends on where you get subduction, magmas. So then these are going to crystallize They're going to crystallize in volcanic arcs and island arcs. If you don't remember what those are, you should go back and refer to chapter 3. because it talks about plate tectonics. These volcanic arcs are then going to be andesite or diorite, because remember some of the magma will crystallize below the surface, below the volcanoes, and those will be diorite. The one that gets ejected onto the surface will form into andesite. When you partially melt, your andesite and diorite. So, this is going to occur at subduction zones and collision zones until there's no more oceanic crust to subduct. You are going to produce your intermediate, depending on the rocks you're partially melting, and felsic muds. These will crystallize and they will form continental plutonic rocks. Remember, those are the ones below the surface. So these are going to be intrusive rocks in continental crust and or melting of deep sedimentary rocks. These are going to be rhyolite and granite, because those are your felsic igneous rocks. And this is the process that occurred, this is the process that occurred to get from ultramafic to granitic. And then the granitic built up the continents. So a really important fact is all igneous rocks result from magma differentiation. Which, if you don't know the different types of magma differentiation, or that word doesn't sound familiar, you should go back and read the textbook and or watch videos from the previous sections. So if we look at the slide here, this is basically showing you part of the crust and the asthenosphere, so the lithosphere and the asthenosphere, and it's showing you where you get the different types of rocks. So here's a hot spot, so you do get basalt at hot spots. You get your decompression melting of your ultramafic rocks, which forms your basalts of your oceanic crust, and your gabbro. Your lithosphere is made of mafic igneous rocks. Here's showing you a subduction zone. You're getting partial melting, and you're getting intermediate igneous rocks. Over here, same thing. You get, here's another hot spot. It's coming through the continental crust, so you're going to end up with felsic rocks and rhyolite at the surface. So at subduction zones, you primarily do get andesitic rocks, and we'll talk about that when we get to the next chapter, chapter 6, with volcanoes. That volcanoes that are made out of andesite are the most common type because they're related to subduction of oceanic crust. So this is showing you a hot spot, so this would be like Yellowstone. So not all the magma makes it to the surface, and some of it solidifies below the surface, and you get granite. What does make it to the surface turns into rhyolite.